was Joe last week, right? So that's easier to do. But what if you want to sell services to customers like that if there was a problem somewhere in this area, show me everybody who was closer than 5 miles or within a 30 minute distance from that area in the days surrounding when the problem happened, right? You're not looking for a needle in the haystack. You don't even know what you're looking for. You might want to compare two haystacks and just show differences, things like that, or similarities, right? And when you have a powerful backend like this, it actually becomes possible. And where the Gluent part comes in is that you don't have to change code. So it was not like a re-platforming task. We did not export data somewhere and shut down Oracle and launch Gluent. It was the same database as it always had been. The app was exactly the same, but we just offloaded some data and we kind of transparently virtualized one day with it. So, and then they started thinking that, hey, we can actually, in addition to running queries faster and cutting costs because my database is smaller now, right? We can actually start selling new services to our customers. Yes?
Where does the Hadoop reside? Is it on a separate hardware?
Yeah, it's a separate hardware, yeah. So you still have your Oracle system with your storage array, and then usually next to that you have this multi-node Hadoop cluster with its own disks attached to it. Separate hardware, and we provide the glue between. So the hybrid part is the glue between. And we've had cases where the Hadoop happens to be in the cloud or in a different data center in a different state as well. So that's one use case. Again, you didn't have to rewrite code, right? So that's the whole point, why we started Gluent. Is that how can you extend or enhance your existing apps with the power of Hadoop? And I think that's what the main point of hybrid world is. Let Hadoop do what it's good at, scanning and analyzing a lot of data, and let Oracle do what it's good at, transactions and your existing code. Your developers can still write existing code, but they don't have to learn Spark or anything. So I kind of got into this topic, so I'll just go through this. It's not all or nothing. We are not doing the hybrid world is not about storage virtualization. It's how it should be done really is schema level virtualization. That the typical application story what we see is that you start with a monolithic data model that we call. Everything is in your Oracle database, right? And it has all the problems what I mentioned, like scalability and performance-wise. So I'm not going to even read through this. And the question about how much we can offload. So once you have Hadoop sitting next to your relational database, well, one option is we do 90/10. The simplest where we usually start from is that, hey, we have this big application, and it has 500 tables in a schema, but only 5 tables are big, right? So we ignore the other tables. We just take the history of these 5 tables, and we move the history, we sync it to Hadoop, and thanks to the transparent query capability or the virtualization capability, it looks to the application user, it still looks like all the data is in the database. So your application query still logs into this schema and runs a join against the same tables here, but this one table is actually virtual. And if for the database guys among you, this is basically a union all view. A union all view which takes most recent data from Oracle, and everything else comes through our connector, and we push down whatever heavy lifting you do.
Does this work with Vertica?
Does this work with Vertica? No. So we haven't done it yet, and we only have asked. People have asked a couple of times about it. So with Visa, no, not yet. Because number one, Oracle was the biggest slice of Fiverr to start from. We do have SQL Server as well. It's not as good as Oracle yet, and we have Postgres is planned as well. Some customers who want to actually slowly migrate over to Postgres, when they have many apps, they would want the same benefits for Postgres as well.
So once you set it up, it's all pretty seamless. I don't have to worry about like the files and partitions in Hadoop. Management of those is taken care of.
Once you set it up, it's pretty seamless. And exactly, yes. That's what we call orchestration. Is that if you just install Hadoop by yourself and run these native Hadoop commands like scoop or whatever, there's so many other tasks you have to do partition data properly, you know, you compute stats and stuff like that, and when you have to present the data back to the database, so it's very tedious, right? And we've taken care of all of that.
Yeah. Your agent runs on the Oracle server, I suppose, but you're actually handling the migration of the data as well, creating the tables and all of that.
We handle the migration of data, you know, from the database to
and
Hadoop.
managing the synchronization of that.
Yeah, we manage the syncing. So the problem is we sync your database or schema to Hadoop, and we keep it in sync.
Okay.
You just run one command, right? And the arrow goes the other way is that whatever data you have in Hadoop, I don't care where the data came from, right? You can query in your database.
Is it real time or is it scheduled?
Is it real time or is it scheduled? As of today, it's scheduled,
Okay.
but we can do incremental extracts. Real time is on the roadmap as well.
Okay.
And so just visually, I have some more use cases to show what other customers are doing, but visually, so that's, you see, the previous one was 90-10, but what if somebody wants to see the whole data set in Hadoop? Because you may have analysts or data scientists who want to run Spark or something on the data set directly. So we can do 110. So basically, you see 10% is still in Oracle, 90% is virtual, but the whole data set is in Hadoop. So there is a bit of an overlap, but this union all view which we have, it takes care that you don't see overlapping data. So, and it gets even a bit better. You may actually want to even sync these smaller tables to Hadoop as well. You know, you don't want to, you don't sync them to Hadoop for storage saving reasons because they're fairly small. But if the data scientist wants to see all data, they want to actually go log in directly to Hadoop and then query the whole data set, they can do that as well. And there was a question before that, can we update records if something changes here? Yes. So I can explain how it's done later.
So are you also a disaster recovery function?
Are we also a disaster recovery function? So I would say small, yes. It can be a part of your recovery strategy. So the term would be logical backup. So we went to a bank and we explained this, and they were like, "Hey, you could use Gluent and you could use Hadoop, maybe with Gluent as a logical backup as well." And then they told us a story where they had a regulatory requirement that they needed to restore data from 7 years ago for some regulatory request. So I guess somebody was going to go to jail or whatever. But so they went to their backup tool. They restored the Oracle files from 7 years ago. That was successful. But then they realized that they couldn't open these Oracle files with Oracle anymore because it was Oracle 7, Oracle version 6 on IBM AIX 32-bit platform, like a very legacy platform. They didn't even have such a server around anymore. So they couldn't open this file because it was a proprietary Oracle binary format. It wasn't an open data format, right? So, and then they had to go to IBM, and eventually they found a server from IBM, and they finally could open. And but these guys realized that, hey, you could have Gluent and Hadoop as a logical backup. That whatever data you have, you will sync that to the cloud or Hadoop, and it's in open source data formats. And they don't really change. I mean, they change and improve, but it's not like your Oracle version goes away and you cannot do anything with it. So open data formats are usable by all platforms. So that was one use case. So you can have 100% in Hadoop, but then and you see the main one of the points for that is that you can let your data scientists loose here. They're not going to cause trouble in your important database. Right? They can do whatever they want in Hadoop, and run and ask crazy questions which you never dare to ask in your database, right? And not impact the SLAs of the database.
So they have like high views essentially of the data.
High views, you mean?
Like from the data scientist perspective in only the Hadoop world,
yeah,
they just look at it as a Hive table. Right?
Yeah, from the data scientist point of view, these tables show up in Hive Metastore, so you can run Hive queries, you can run Spark, SQL on it, you can run Impala, and so on. So it's the same data model usually. So we don't try to ETL it. Even though we can pre-join tables and so on, it's a familiar data model, and that's kind of a plus, right? So it's a familiar data model, and then you see what to do with it. And so I'll show you one more use case about a customer here in Texas as well, but. What about this? In the new world, a lot of data lands in Hadoop first or Hadoop only. Now that's a big change, right? 7 years ago, you built a system. It had to be reliable. It had to land in Oracle or DB2 or whatever because MySQL and so on, they were not good enough. You know, they were not certainly scalable enough. But now Hadoop is a enterprise-grade scalable system, where your IoT feeds, web logs, and a lot of these really big data sets land. Especially the events which have happened somewhere else, right? Web log is an event which happened in the web server, and nobody modifies it anymore. It already happened. All you have to do is kind of query and analyze it. It's not transactional. So one of the use cases that I'll show is this. That I have this really big data set. I don't want to load it into my database. I don't have space for that. I don't have time. I don't want to spend all the licenses and detailing. You can just present this data set to the database, right? And it shows up as a virtual table. So you can just change your query, add one more table in the join. So you don't have to ETL data around and first load it in the database to use it.
How do you take care of like you know, changing schemas all the time? You know, because web analytics, it's very, I mean, there are like 3,000 potential variables. You don't know which ones are important any given day.
So how do we take care of changing schemas? I mean we have. I mean, you mean like when something changes on Hadoop side?
Like all of a sudden, some application decides to add like another field, right?
Okay, so I mean, I think when schemas change on this side, on the database side, we have something called schema evolution support. When somebody adds a column, we will go and add it on the table as well. When you next time you sync, right? When somebody drops a column from this side, we don't even drop it in the other side. But our connector is smart enough to know that it doesn't exist in the database side anymore. But the column still lives on in the other Hadoop side, if you want it for archiving reasons.
Yeah, you may need it for legacy records.
Yeah, for legacy records, you may need that.
Let me get this straight. So say, for example, you have 20 columns,
Yeah.
right? Initially, there are only 20 columns here. All of a sudden, a new app came and they added 2 more columns, right? On the weblog side.
Yeah.
How do you manage the web? You know, if the 2 columns need to be added to the left.
Yeah. I mean, that if somebody independently adds columns on the Hadoop side, for example, we just present
would you
again.
manage it from like one of the biggest problems is like if I create a hide table on the right side, right?
Yeah.
Then I have to again modify that hide table. If you provide me the virtual table and if I just do that one job there, and if it seamlessly takes care of updating the schema on this side, that would be useful for me.
Yeah, and we do that. It's called schema evolution, or we call it schema evolution. The only conflict, I mean, and in all the cases can be handled pretty automatically. The only cases where somebody renames a column, right? So, you know, so right now we just say, hey, somebody rename the column, you decide what to do, but we can even automate that. So, but you know, we built in all kinds of checks that we wouldn't return wrong data or anything like that. So, and the use case for this is, so this is actually, so I have a few more use cases, and then I will open up here and start answering questions. So there is actually a large, one more use case is from one telco. It's kind of similar to the past one or the previous one. So they had a big table with call detail records, and they could keep only 90 days of history on their expensive all-flash storage, and you know, it was slow. Queries were slow. They were doing large analytics again. So what we did, we went in and we offloaded 89 days out of 90 days, and then ran the same queries again. So previously, when they wanted to query 1 day worth of info, it ran in Oracle 33 seconds, right? When they ran the 3 days, when they wanted to query and aggregate three days worth of call detail record history, it ran for 2 hours. And 7 days was 6 hours. So actually the query did I/O, you know, and fetched data and aggregated and blah 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 blah. And it took 6 hours. And they didn't even dare to run any longer queries because they never completed, right? So we offloaded 89 days, and then we actually, just for the fun, we offloaded 90 days. We offloaded the whole thing as well, just to show what happens if everything is in Hadoop. And instead of 6 hours, the query ran in the 90-10 mode. It ran for like 2 minutes, and when it was all Hadoop, there was no Oracle component, you know, in that table at all. It was only 1 minute, right? And then usually what happens when they see this is, okay, I want to run the whole month, right? And they ran the whole month, and it also ran in 2 minutes. They didn't see much of a difference, right? Because again, Hadoop, with its columnar data structures and directly attached disks and the scalability, it's just so much better at doing this stuff. Not complex OLTP, like I said, right? Complex OLTP, do it in your database. But scanning, filtering, aggregating, analyzing large data sets, that's where Hadoop is a killer. Yep, one question.
Does Hadoop use silos and that type of stuff?
Does Hadoop use silos?
Silos?
Yeah.
So
For storage?
no, so basically Hadoop, look, physically, if you have a 10-node Hadoop cluster, you have 10 little servers, and each server has 12 disks right in it. So you have like physically you have 10 independent little servers with disks right in them. But thanks to the software layer in Hadoop, it all looks like one logical big machine, right? You can run you can connect to any node pretty much, run a SQL statement, and this SQL statement gets parallelized across the whole cluster and pulls the results back. So physically, it's a bunch of separate machines. Logically, it's a one hybrid system. It's a distributed system.
There's fault tolerance built into the data storage?
And fault tolerance is built into data storage, so you don't have to go to EMC to get mirroring because it's open source, it's all there. Yeah.
I'm still thinking about the question from the slide previously that this gentleman asked about this schema synchronization. I mean, based on what little I know about Hadoop, there's really not really a schema as we think of it in an Oracle world, right?
Yep.
So when two columns suddenly appear on the Hadoop world, and I can't even say the word column, I don't even know what to call it in Hadoop world, is the Gluent product still smart enough to make that mapping, to know, to recognize that two new data elements have suddenly appeared in this big web log that I now need to make visible and present over in a traditional Oracle world? Is it Gluent figuring that out, or what?
So it has changed. When Hadoop was first invented, it didn't have any schema. It didn't have databases. It didn't have SQL. It only had a distributed file system, and it had MapReduce, manual Java engine on it, right? But then when Facebook invented Hive 8 years ago, as part of Hive, they invented something called Hive Metastore.
Okay.
And Hive Metastore is like a data dictionary for Hadoop, or your catalog for Hadoop.
There's an implied presence of Hive Metastore running in what you're saying up here.
Yeah.
Okay.
And nowadays, when you download or buy a modern Hadoop distribution, then it comes included. You have HDFS, you have MapReduce, you have Hive Metastore, you have Hive. And then depending on the vendor, you have, let's say, Impala SQL engine, which can also use Hive Metastore. Right, and then you have Spark, which can also use Hive Metastore. So as far as the schema goes, is that in Hadoop, when you look into the file system level, you just see a bunch of files, right? But the schema is sort of applied on these files. So when I do a select star from some table, table in Hadoop, then my query engine goes to Hive Metastore and sees that, hey, in order to show this table to the user, I got to go to this directory, go through all these files, and read this file using this specific manner. And these will be my columns. Okay. So schema will be applied. I mean, schema doesn't have to, but can be applied on files in Hadoop.
Okay. Thank
but to the end user, it looks like a database. So that's how much it has evolved. We are close. I have a couple of more examples. This is just more of the same. So there is another company who had multi-year reports. They did not dare to run 5-year reports. They were selling services to their customers. Their customers wanted to analyze 5 years of data at a time. They could not. They could only afford this to they only sold it to one customer who was the most important. Others could only query like 3 months, right? And when we enhanced this with Hadoop, well, one of the big reports, instead of running for 2 minutes, it just ran for 18 seconds. So these are different queries as part of the report. And it actually took 24 times less CPU because Hadoop was doing most of the heavy lifting and Oracle did the final, wrap up and formatting. Just performance, that's the same. That's interesting because we actually, for one customer, we used this, Oracle has a performance repository where it keeps track of your worst SQLs or the biggest, most frequent SQLs. And we wrote a little script which ran all 5,000 SQLs in there, in a loop, right? Just to make sure that everything works and doesn't work as fast enough, and so on. And these queries each query was about 1.4 seconds. And afterwards it ran in 0.7 seconds on average. And it used 50% less CPU. And this hopefully answers the question that people often ask that if you go from this monolithic database to a hybrid system, so how much slower things will get? Well, if you run long queries, and long queries here is like a 2-second query, right? So if you run long queries, then it goes faster. Because in this case, we did not use Hive in the backend, we used Impala, which gives you low latency queries. Don't do this for heavily transactional apps. And when your query needs to be 10 milliseconds, so that's where Oracle is very good, or MySQL, or whatever database you happen to use. But if it's analytics, scanning through a lot of data and doing something with it, then then this is a viable approach. Or if your OLTP system has a long tail of history, your transactions and modifications happen on recent data, but you still have 7 years of history, then that history of your OLTP database can be moved as well. And I'll show you the last use case, so then we can go to Q&A. So this is actually an interesting, it's actually an energy company in Dallas, right? Where we started from offloading as well. It was a big SAP data warehouse, too expensive, too slow. Can we make it smaller and cheaper, right? And use Hadoop as the heavy lifting backend, right? So that we started from that. But when we were doing that, then one of the questions that came up that, hey, we already have some smart meter data in Hadoop as well, and can we query that, right? And yes, because we had this hybrid connectivity between Hadoop and the database, we could do that. So it was possible to query, join together customer data in the database, in the Oracle database, with this big IoT data set in Hadoop, right? Previously, if you had such a question, is it possible? You had to buy an ETL tool and buy more storage and load the data in the database, and then you ran the query. And sometimes it was like a 5-month project, right? But if you can combine Hadoop and your databases like that, then just becomes much faster from the development process point of view as well to try out these things. And I think Jerry will actually speak at the Enkitex conference in June about that as well. So the point is that this approach is not only for offloading your databases, but it can be really useful for enriching your existing apps with whatever modern big data or IoT data you may be collecting. And without having to rewrite or load all the data to the database. So you have hybrid queries over all enterprise data. I realized that there is one fancy looking one more, so I'll just do this. So this is a telco, actually the same telco who had the performance increase. Once they saw the performance benefit, they started thinking further. And the application owner said that, hey, I actually own 24 applications in a constellation, right? And all the applications actually required access to the call detail records. A lot of data which comes through the telecom switches, right? So who called whom and how long they were talking for and stuff like that. And the old school way was always to load all the data. You allocated terabytes of storage here, you allocated terabytes of storage here, and you have ETL jobs and feeds, and you loaded the same data set to all 24 databases. A lot of storage, a lot of I/O bandwidth needed, and then it just gets slow. And now what they can do is that, hey, they just have a more powerful Hadoop cluster. You store the data once, and then anybody who wants to, any application who wants to, and has permissions, they can just query. And not only access it, but also any heavy lifting is pushed down to Hadoop. So a lot of architectural opportunities. So, and Gluent is one vendor who does that. If you look into the list, there are other vendors who have something similar. Obviously, we do it better than anybody else, but I think architecturally, this is where the world is going, because these databases, they're still very good at some things. It's very hard to rewrite all your 1,000 apps in the big enterprise, but you still would want to benefit from the power of modern platforms like Hadoop.
Do you have like reverse of what this is, like where I want maybe there's a table out there in Oracle that I want to see as a Hive table?
Yes, so do we have a reverse of that I would want to run a query in Hadoop and it pulls in data from Oracle Transparency or something like that? So we haven't done that yet, and the reason is that when people say that, hey, I would want to run a query in Hadoop and query data from Oracle at the same, within this hybrid query, we usually say that you should always sync whatever data you need from your database to Hadoop anyway. because Hadoop is cheap enough,
So
right?
it's probably better to
yeah.
do that.
And that's when we, say that, hey, sync your big fact tables, but sync all the dimension and the customer reference tables as well. So then you don't even have to reach back to the database, right? But we someday will do that as well, just for more flexibility.
So where are the queries being run here, on the Oracle databases or on the Hadoop?
So where are the queries being executed in this case? Well, actually, it's a hybrid query. So the application still logs into the database exactly as it did yesterday. And the application still runs exactly the same query as it did yesterday. And this magic now, this magical hybrid layer, it will pull parts of your query, the heavy lifting parts of the query down to Hadoop, and it uses Hive or Impala to run these parts of query in Hadoop. So this query runs actually in a hybrid way across both sides. It runs on Hadoop and Oracle as well. But usually most of the heavy lifting, most of the I/O and CPU happens on this side.
How
So-
does the access security work?
How does the security work? So it's so the cool thing is actually is that even if you didn't do anything here, then when you virtualize a table, right? If a user Joe did not have access to the original table, the user Joe will not have access to the virtual table either.
But what if I directly go to the Hadoop store and
Yeah, exactly. So this what I just said only applies when people still log into the application. So nothing really changes in the app side. But when somebody logs in straight to Hadoop, then you will need to apply Hadoop site security. So because as I said in the beginning, 7 years ago Hadoop really didn't have security, but now Hadoop looks quite like your database, right? If your users log in via Hive or Impala or a SQL engine, it looks pretty much like Oracle. You can grant select on this table to that group, right? Or you can grant insert on that table and so on. So for different, it's like a database, right? So Hadoop has gone a long way regarding security as well.
so when you synchronize the table, you can apply Kerberos security or whatever security that.
Yeah, whenever our layer connects to Hadoop to do anything, so it can use Kerberos for or it can use LDAP if it's Impala or Hive, right? So for authentication, and then normal Hadoop security permissions apply. And we do encryption as well, encryption in flight. And the Hadoop itself has, as I said earlier, every single directory in the HDFS can be encrypted by a different key, which is pretty cool because you shouldn't, if you have 24 databases here, you probably should not deploy 24 Hadoop clusters. You want only one or maybe two, every business unit can have their own encryption keys and manage it by themselves. So it's pretty secure now as well.
And how does your licensing model work?
How does the licensing model work? So the guy back there can answer in more detail, but our point is that if we liberate data from the Oracle and Teradata and IBM and EMC world, right, it doesn't make sense to do it when it's only 20% cheaper, right? It needs to be way cheaper. You need to be able to do way more things. It needs to be way cheaper as well. So I'm not a sales guy, right? So that's where I will stop. But we have a sales guy in disguise back there, wearing a T-shirt.
If the slide will be available?
Will the slides be available? Yeah, I'll put them somewhere, and I'll send a link to the meetup page, so you all should get a notification. And I think if you want to take a photo already, then there is a video. If you want to learn more immediately, then this is like 1.5 hour video, more technical details. Some of the stuff is the same, but we dive into execution plan details and stuff like that. Yes.
So I understand the single is bidirectional, both from the data.
Yeah. So is it like bidirectional? So it's bidirectional in the sense that you can offload data or sync data from your database to Hadoop. That works only one way. You can only sync from here to here. And then the other way is that you can, inside Oracle, you can query data which resides in Hadoop. What if you want to do other ways? So it's actually pretty cool because you can query with the hybrid query, you can query any table that's in Hadoop, right? You can run select from that table. So, but if you actually want to move the data back to Oracle, then you will just say insert select, right? Or create table as select. So whatever you can select, you can also insert select. So that's how we can move or load data back to Oracle, via just a query, right? But data sync. So what was the last part? Well, actually, that's how we get data back. And but the last part, what we don't have yet is that you cannot run. I mean, our Hadoop queries, which you run on Hadoop side, they don't reach back to the database, right? And the reason is that we just say, hey, the storage is cheap enough. You probably should sync all your small tables to Hadoop as well. So then there is no reason to reach back to the database, unless you really want really high, low latency, real-time replication stuff, and that's coming as well today. So yeah, we like Hadoop. We still like Oracle for some use cases, and I think the hybrid world gives you the best of both worlds. And thank you very much. And I'm going to grab a beer and I will answer questions.